Hello, welcome to this session of the Medication Mathematics course. Today we will continue our discussion on weight-based calculations, and we are going to look at weight-based maintenance IV infusions. Sometimes we need to give IV fluids at a precise volume and rate to prevent overload. When we say overload, that is too much fluid that is more than the heart and the body can handle. And so we are going to be using 5 basic steps to do this. Let's begin by looking at a question. The provider has prescribed sodium chloride maintenance fluid for a client who has respiratory infection using the dose instructions below. At what rate and volume should the nurse set the infusion pump for a client who weighs 17.6 pounds? So these are the instructions. It says for 24-hour fluid maintenance volume, the requirements are for every 10 kilograms, we should give 100 mLs per kilogram up to 10 kilograms. We should give 50 ml per kilogram for each kilogram between 10.1 and 20 kilograms, and then 20 ml per kilogram for each kilogram over 20 kilograms. The maximum for 24 hours for males is 2500 mLs, and for females is going to be 2000 mLs. So let's go through our basic steps. Step 1 is to convert the weight from pounds to kilograms. And we know that to get weight from pounds to kilograms, we have to divide by the factor of 2.2 pounds, because 2.2 pounds equals 1 kilogram. So let's set this up. According to our question, the client weighed 17.6 pounds. So that is what we have. So let's write that down, 17.6 pounds. And we need to convert this to kilograms. So we said if we use dimensional analysis, in every 1 kilogram, we have 2.2 pounds. Therefore, our pounds will cancel pounds, and now we have 17.6 divided by 2.2. So let's use our calculator and find out what that will amount to. 17.6 divided by 2.2. And this is going to give us 8 kilograms. So our first step is done. We have 8 kilograms. We can also use the method, the formula method. We know that we just divide by a factor of 2.2 when we want the weight from pounds to kilograms. So we can simply do 17.6 divided by 2.2, or 17.6 divided by 2.2. Once we enter this in our calculator, we should be able to still get 2.2. The second step is to distribute the weight by tens and ones. Remember, we talked about tens and ones. And so for our weight of 8 kilograms, we are just in the category of ones. And so there is no distribution. What if we had a weight of, say, 25? Then we can have 10, 10, and 5. We will look at some examples that will have more than 20 pounds. But let's go on. So we have only 8 kilograms, and so we do not need any further distribution. Then the third step is to multiply each fluid distribution by the appropriate weight distribution and sum them up. So we only have 8, and it says, the question says, for us to give 100 ml per kilogram for each kilogram up to 10 kilograms. And so what we are going to do is, we don't have more than 10 kilograms, so we will just multiply this 100 ml per kilogram by our weight, which is 8 kilograms. So kilogram will cancel kilogram, and then what we have is 800 ml. So this completes step 3. Then we move on to step 4. Step 4 is to find the infusion rate. And we do this by dividing the total volume by the time for infusion. So for maintenance fluids, we know that this is going to infuse over 24 hours. Do we know our total volume? Yes, we do. We calculated that to be 800 ml. And so if we know that our rate is equal to the volume over time, then this is going to imply that 800 divided by 24 will give us our rate. Let's do this and see what we get. 800 divided by 24, and our rate is going to be, let me do this well, my pen is not cooperating. Okay, so this is going to be 33.3333. So this means that it's recurring, so we're going to have 0.333 to infinity, so we're going to just cut it off there. Okay, now we move on to the 5th step. So step number 5 is to convert the required number to the required number of decimal places. For maintenance infusions, according to the rounding rules, we are supposed to leave that at 1 decimal place. Okay, so let's write our rate. So we found our rate to be equal to 33.333 all the way to infinity. So what we are going to do is, if we are leaving this to the first or 1 decimal place or the 10th, we are going to count 1 after the decimal place. So we're supposed to leave our answer to only 1 decimal place. And so this is 1 decimal place. Then we will consider the number after the decimal place. and determine if it's equal to or greater than 5 or less than 5. So 3 is less than 5. If 3 is less than 5, then we are going to delete all these subsequent numbers, and so our final answer will be 33 0.3 ml per hour. Always don't forget to add your units. Okay, so 33.3 ml. This is going to be our rate. And so when we program the pump, we are going to enter a volume of 800 mLs at a rate of 33.3. And that is the end of the solution. All right, so now let's see what if we had more than 20 pounds. So let's solve the same question for a client who weighs 48.4 pounds. The first thing we said to do is to find our weight, and so we are going to do that. And so we have .48 0.4 pounds, and we want to convert this to kilograms, and so we are going to just divide this by 2.2 pounds. And then that should give us our weight in kilograms. So let's use our calculator. 48.4 divided by 2.2. That will give us 22 kilograms. So we know that our weight is equal to 22 kilograms. Now, our second step is for us to distribute this based on the weight distribution. So we have this will be equal to 10 plus 10 plus 2. So we have 2 10s, and then these are our ones, okay? And that. So the next step will be to find the total volume that we have to infuse. So we will go back to the question and see the weight distribution. It says for every ml per kilogram for the first up to 10 kilograms. So we have times 10 kilograms, and then the question also says that for the next 50 ml we give that for each kilogram between 10.1 up to 20 kilograms. So we will have 50 ml per kilogram times the second 10, which is this 10. So we have accounted for this 10 and this 10. And what is remaining is just 2 kilograms. So we look at what the next criteria is, and it says the next should be 10 ml per kilogram for each kilogram over 20 kilograms. So 2 is what we have, that is over 20 kilograms, and therefore we are going to multiply that by 20 ml per kilogram. This is going to give us 1,000 mLs. This is going to give us 500 ml. So we are just multiplying. And then this is going to give us 40 ml. Once we have found the fluid distributions, then we sum it up to find the total amount of fluid that we have to give. So we have 1,000 plus 500, which will give us 1,500 plus 40. So we are going to get 1,540 ml. So this is our total volume. Now that we have our total volume, we can find the rate by dividing this by 24. So our rate will be equal to volume times time, which is 1,540 divided by 24. So this is hour, this is ml. Let's do that on our calculator and see what we will get. So we end up with 64.1666 7. Let's then find our answer to 1 decimal place. And we note the number before or at our decimal place. So this is 1, and then the number after it. This is 6, and this is greater than 5. So if it's greater than 5, then we increase the number at our decimal place by 1, which will be 2. So we will get 64.2 as our final answer. So our volume that we will program in the pump is going to be 1,540. And then our rate is going to be 64.2 ml per hour. Now, I must say that when you begin clinicals, you will never find an IV infusion bag that is more than 1,000 cc's. So in Safe Medicaid, or when you have the question, look at the supply that you have, and it may just be 500 cc's or 1,000 cc bag or 1,000 ml bag. And so when you are programming the pump, instead of this overall 24-hour volume, you are going to make sure that you use the 500 ml bag that you have in supply, or the 1000 cc bag that you have in supply as your volume. And when you begin your clinical practice courses, you will talk more about how to find out how much fluid has infused. You can easily find that by using the formula method that we talked about. So we know that rate is equal to volume over time. So if we know the time that has elapsed and we know the rate, we can find the volume. And we can also find this just by using the pump and going into the settings and finding out how much fluid has infused. So this brings us to the end of our fluid maintenance calculations based on the client's weight. I will see you in the next session. Thank you.